So welcome to all of you in video based IT training. In this video I'm going to explain you about the subnetting. What is subnetting, what is the use of subnetting, and how we can do the subnetting. So in my previous video, as I have explained you about the classes of IP, how many total hosts can exist in an IP, and all that stuff. So if we go with this part, network and host part, here I have explained you, like in C class, this will be the total IP series 192.168.1.0. This will be the when all the host bit are 0, that is known as the network ID, and when all the host bit is 1, that is known as the broadcast IP, and this will be the valid IP that I can configure on different devices. So if I configure all these IPs in simple way as it is, so what happened, all the machines comes under a single broadcast domain. Means any of the machine from here, this network create a broadcast packet goes to all the machines, means all the 254 devices. If we go for the B class, here we can just come to this slide, this one. So as I've told you, in C class maximum IP can be 254 valid IP. In B class it can be 65,534, and in A class it can be 16,077,000, more than that. So such a big broadcast domain. If a single machine create a broadcast here, go to all the 65,534 machines. And so the main purpose of the subnetting is to break a big broadcast domain into small subnets. To reduce, why? To reduce the broadcast domain. What does it mean? So rather than going to the broadcast packet, all the 254 machine in C class, I can break that big network into small subnetworks, because broadcast is the biggest devil in the network. Why? Because it consumes a lot of bandwidth. If a single machine creates a broadcast packet, it goes to all the machines. So first it will consume a lot of bandwidth, and naturally that machine whichever received that particular broadcast packet have to process my switches, have to forward the broadcast packet, machine have to check that broadcast packet, is it particular packet belong to that particular device or not. So naturally it will also unnecessarily utilize the network resources also. So the two main problem with the plain IP series, if I configure first the bandwidth consumption, so reduce the network performance, and second, unnecessary utilization of network resources. So for that purpose we do the subnetting. So subnetting means to break a big broadcast domain into small subnets. So let's see how we can do that. So for example, first I'm going to take C class IP series. So this is my network ID, for example, and this is the default subnet mask. It will be the valid IP series, and this is the broadcast IP. So now my purpose is to break this network into small subnetworks. Depending on my requirement, I can break this big network into small subnetworks. So for example, right now I'm going to start from very beginning. Suppose I have to break this big network of 254 into two subnets, or you can say in my organization there are two different departments. One is the suppose marketing department, and one is the sales department. So I need two different subnets. If any of the broadcast packet generating in the marketing department will not impact the sale department, and if any creating on the sale department will not impact the marketing department. So to reduce the broadcast domain, broadcast domain will be this and one broadcast domain will be this. It will not interfere here and this particular will not interfere here. So naturally it will reduce the broadcast size. Okay, so let's start this process, how we can do it. So it's nothing complicated, just need to have a understand the concept, how we can do that. So default is this one. 192.168.1.0 is the network ID that I want to divide in two different subnets. So to do this, we have to use the formula 2 raised to power y, number of subnet required. How much subnet I require? So in this case, what is y basically? Number, what is this y? Y is number of bits to be borrowed from host to network side in a subnet mask. This is my subnet mask. So by default it is the decimal number system for human being, but computer does not understand it. Computer always work on the binary. So 55255 255 255 means all 1, and this if I convert into the binary 1 2 3 4 5 6 7 and 8, if I convert all to the binary, remain all is the 1 1 1 1 1 1 like this continue. Okay, so these all are the network portion. So I cannot do any change in this area. I have to play on host bit only when we are doing the subnetting part. So again revising the formula, very simple formula, 2 raised to power pi number of subnet required. What is y? Number of bit to be borrowed from host to network side in subnet mask. This is my subnet mask. So in this case I require only 2 subnets, means 2 raised to power, what value should I place here so that I get the value? That is a 1. 2 raised to power 1 is equal to 2. Means I need to borrow, in this case I need to borrow 1 bit from this host portion to network side. So I convert it by default, this one, these all are the ones, means network bit, and this is the host bit. So if I convert it, I borrow 1 bit from, this was the host portion, so I borrow 1 bit from host to network side. Hope it's clear to you. So very simple formula, nothing complicated here. Just always whatever subnetting you are doing, you have to keep in mind this formula. 2 raised to power y, y number of bit to be borrowed from host to network side in a subnet mask. So when I borrow 1 bit, so what will be the new subnet mask? So the new subnet mask will be 255.255.255.128. When I convert this particular binary number to the decimal number system, it will become 128. If you remember all, I have explained you very well how you can convert decimal to binary and binary to decimal. So just you can see my previous video also if you still have any doubt in there. So this is the first process to calculate the new subnet mask to fulfill this requirement. This is the first step. So next, when I divide a big network into 2 portions, so naturally every block or every subnet, 2 different subnet will have a specific number of IP in each block. Next is the block size. What will be the block size? How many IP can exist in single block? So when we divide a big network, each subnet or block will be have a specific number of IP. So what will be the block size? There are two methods to do that. I'm going to explain you first one. So the block size will be 256 minus the value of interesting octet in a subnet mask. So what is this interesting octet? Where the change take place in a subnet mask. So the change take place in 4th octet, this octet. So what is the value? What is the new value here? 128. So the block size will be 256 minus 128. Okay. So this is one method. 256 minus value of interesting octet. Or second method, suppose right in this case, how many bits we are borrowing? 2 bits. So what is the value of last bit that I have borrowed? In this case I have borrowed only 1 bit. So what is the value here? 128. So this is also the block size. In my next example I will show you if I borrow 2 bit, I have borrowed 3 bits. So simple method is this one, 256 minus, suppose that I will explain in my next video. So the simple method, 256 minus the value of interesting octet. So in this case interesting octet is 4th octet, so the block size will be 256 minus 128. So the block size will be 128. So means each subnet or block will have 128 total IP in each block. So this is the second step. First step is to calculate the subnet mask using the how many bit we require to borrow from host to network side according to the requirement. Then calculate the block size. So last point step, what will be the different subnetworks now? Okay. So as I've told you, in each block there can be maximum 128. So you can see here 0 to 127 IP. It will become 128. Means in this case 0 will be the network ID, 127 will be the broadcast IP, and this will be the valid IP that I can configure on a device. And second subnet 128. Second subnet 127 is the broadcast here. Difference will be the 128 according to this. So next 128 to 255. This will be the network ID of this particular block. It will be the broadcast IP. And it will be the valid IP series that I can configure on any machine. So now what is the benefit? If I configure these two blocks, this block and this block on the machine, so any of the broadcast generated here will not go impact this. So with the help of subnetting, we can reduce the broadcast domain size so that we can save bandwidth consumption, because this broadcast will not go into this particular network. Okay, so hope you understand C class subnetting. Let's see some more. One more example I want to explain you to make you more clear. Suppose I require 4 subnet. In my company there are 4 departments and I want to reduce the broadcast size according for that. Means I want to break a big network into 4 subnets. Same IP series I am going to use here. Now how I can break it into the 4 subnet? Let's start the process. So again here requirement is 4 subnet. Same formula I have to use, nothing different. 2 raised to power y number of subnet required. What is why? Number of bit to be borrowed from host to network side. So how many bit, what a value I should place here so that I get the value of 4. So 2 raised to power 2 means 2 multiplied by 2 will be equal to 4. Okay, means I need to borrow 2 bit in this case. Okay, so default subnet mask is this one. I need to borrow 2 bit, so I borrow 2 bit here. You can see from the host to network side. So what will be the new subnet mask here? It will become 255.255.192 will be the new subnet mask. Same process again. Now I have to calculate the block size. Same definition that I have given you. Each subnet will get a specific number of IP. The same formula 256 minus value of interesting octet. So what is the value of interesting octet here? 192. So if I go here, so in this case block size will be 64. And I have says you there are one more method to calculate the block size. What is that? Here I have seen, if I go with my previous method, 256 minus value of interesting is 64, or what you can see here I have borrowed 2 bits, it's a 128, it's the 64. So I can also find out the block size from the last bit borrow. So the last bit borrow is this particular bit. So this bit value is 64. So we can calculate the block size in this 2 way. Okay. Hope it's clear to you. Both the method is clear to you now. If you still have any doubt, can write me in the comment. I will try to explain you again or try to reply there. So the block size will be 64, means each subnet or block will have a 64 IP, total IP. So what will be the subnets? You can see here 192.168.1.0 to 63. It will become total 64 IP here. It will be the network ID of this particular block. It will be the broadcast IP of this particular block. Sorry, my writing is again, I'm saying, very poor. And these are the valid IP. Like this, valid IP. Finally, I have written. Okay. So, in the same way, next block will be the 64 because 63 end here. Next block is 64. First valid IP is 65. Last valid IP will be 126. And broadcast will be 127. 128. First valid IP 129. Last valid IP 190 in the valid case, and it will be the broadcast. And here 192 will be the network ID, 255 will be the broadcast IP, and this will be the valid IP range. Now each subnet will have its own network ID, its own broadcast IP. In this case also, this will be the network ID and this will be the broadcast IP. In this case, network ID, broadcast IP, these are the valid IP series here that I can configure on any device. So any of the broadcast generated here will not impact this particular subnet, will not impact this particular subnet here, will not impact this subnet here. So each subnet, each block will have its own network and broadcast IP. Okay, hope C is very clear to you. If you still have any doubt, let me know. Write me in the comment. I will try to explain you. In my next video, I will explain you how we can do the B class subnetting. Okay, so hope you enjoy this video. If any doubt, please don't hesitate to write me in the comment. I will try to reply you as soon as possible. Hope you enjoyed this video. Thank you very much.